Hi everyone, my name is Smriti Singh and I'm a final year undergraduate who's an NLP researcher by profession. Um, right now, my domain of interest is applying NLP for social good initiatives and healthcare objectives. So today I'm here to talk about NLP and hate speech and why does it matter and what we can do about it. So, for those of you who haven't already seen the outline of my talk, let me just give you an overview of what we're going to be discussing in the next 30 minutes. First, I'm going to start off by introducing hate speech, what it means, and what are the most common forms of hate speech that we see today. I'm going to move on then to explaining why the detection of hate speech is important and why it's a popular field in the research community. And then I'm going to show you a couple of use cases for why machine learning has been used for hate speech detection and why deep learning has been used for hate speech detection. And then we are going to look at both of these use cases and sort of have a contrastive analysis to figure out, with when to use machine learning and when to use deep learning. And finally, I'm going to show you a few open source data sets and libraries that you can use to develop your own models that contribute to this cause. So with that, let's get started. Hate speech is a pretty intuitive term, right? But a formal definition is an abusive or threatening speech or writing that expresses prejudice against a particular group, especially on the basis of gender, race, religion, or sexual orientation. So just from that definition, you can tell what are the common forms of hate speech that we're seeing today: sexism, racism, and stuff like that. And the reason this is becoming such a big problem is a bit of a complex thing. So let me explain it to you a little. In real life, you wouldn't expect anybody to, just walk up to you and say something really rude or something really offensive and just get away with it, right? That's not how that works, because you know that there'd be consequences for that. Nobody could just get away with that. But unfortunately, with the many advantages that social media platforms have brought about with like networking privileges, they have also brought about the so-called cloak of anonymity. And what this means is that somehow people are more comfortable saying things they shouldn't be saying, as long as they can say it online from behind a screen, because it devoids them of any accountability and any consequences for their actions. And to give you some context into the scale of this problem, right? The CTO of Facebook once said that they had to take action against 4.6 million posts that had hateful content in just 1 week. So yeah, that's how big of a problem this is. And it, like, you might wonder, why does this even matter? Like, how does it matter who is saying what online? Here's the thing though, our entire lives are happening online, right? Especially after the onset of the COVID-19 pandemic, we find that our education is happening online, our work is happening online. So it does matter. It does matter to the victims who are receiving insults and offensive, rude comments publicly about things they have no control over. It definitely matters to the victims who are being threatened sometimes on public platforms like Twitter and Facebook. And the thing is, hate speech is usually against minorities. So it doesn't make sense that they have to, withstand this kind of, what should I say, behavior maybe. And there's actually enough psychological evidence to show that hate speech causes psychological damage, like it causes actual damage. Sorry about that. Yeah. So the famous Hollywood actress, right, Ashley Judd, she started something called the Speech Project, and she gave a TED talk a few years ago in which she very nicely explained how neurobiologically we have the same reaction to threats that are received online or offline. Like, it makes no difference to us from a psychological standpoint. And there have been cases to show for, in some cases, like the extreme cases, where these public offensive statements or threats have turned into hate crimes, they've turned into violence, sometimes people have died. So by looking into hate speech and, like, solving the problem of hate speech detection, you might actually be contributing to saving lives. And so let's look at the challenge from a technical standpoint here. One thing is definitely the scale of social media, right? There's no way that a team of people will be enough to solve this problem manually, because there are billions and billions of social media users, and there's so much of content being generated every second. Like even right now as we speak, I'm sure there are millions of posts being generated on social media. So we need AI for this problem, right? And more specifically, we need natural language processing. And even more technically looking at the challenge, using natural language processing to capture the semantic context that signifies hatred, and being able to identify it in a completely automated manner is the challenge. And it's further complicated by linguistic complexities like context and sarcasm and metaphors, and sometimes people use bad words in a way that is not meant to be offensive, that sort of stuff. There is one more issue that is currently beyond the scope of this talk, and it is that in some countries, right, especially the United States of America, the right to free speech is protecting hate speech. So, like, it's not a crime to say something hateful because it comes under the right to free speech. And this is obviously very debatable ethically, but even though I'm not going to go into it right now, I just wanted to, point out that this is also an issue. So for now, let's move on to machine learning and NLP for hate speech detection. And before we proceed, I just want to say that there has been a lot of research done in this field, right? And in the interest of time, I've just picked out a couple of innovative solutions that I thought would, really showcase how the field is developing. So with that being said, let's move on to this project that started at Cornell University. So researchers at Cornell determined that not all offensive language is hate speech. Like I said, context plays a big role in these things. And the difference between hate speech and offensive language is just that, context. So what I mean by that is sometimes offensive language, like terms that are typically construed as offensive language, they are used in contexts that are not supposed to be insulting, like maybe you talk to your friends, or maybe, someone is being sarcastic. Not all offensive language is hate speech. So that's why the researchers at Cornell University decided to have three categories for their text classification problem, which is hateful, offensive, and neither. So for their data set, they collected a lexicon from hatebase.org, and then they used terms from that lexicon to query tweets using the Twitter API. And I want to pause here for a second to explain to you that in the hate speech domain, especially, tweets are a standard data set platform. Like what I mean to say is that, most of the hate speech data comes from tweets. And the reason this is so is that I feel like Twitter is the easiest platform to access this type of content. And that's why you'll find that a lot of work being done in hate speech usually relies on some Twitter data set. So anyway, coming back to this project at hand, right? They used the lexicon from hatebase.org and they queried the tweets, and they got a really large data set. So they subsampled some random part of that data set and decided to have it manually annotated through something called Crowdflower, which is a platform that specializes in data processing. And once they finished the manual annotation process, they found that only 5% of the randomly sampled tweets were considered hateful, but that was still 1,240 tweets. So again, that just gives you an idea of the scale of the problem that we are dealing with. But anyways, for the pre-processing pipeline, the authors decided to convert all their tweets to lowercase, clean up the text. And then for normalization, they used a Porter-Stemmer algorithm. That is an algorithm which basically removes the morphological and inflectional endings of words. And then they generated n-grams according to the weights assigned by the TF-IDF algorithm. Now, for those of you who aren't aware of this, the TF-IDF is a statistical algorithm that calculates the importance of a word in a collection of documents, and by documents I mean any corpus basically. So it does this by calculating two things: how much a word occurs in a document and how much it occurs across the entire set of documents. So it gives you a really good idea of which words are contextually important and which words occur a lot and are contextually irrelevant. So once they had a fully pre-processed data set, they used various supervised machine learning algorithms like logistic regression, naive-Bayes classifiers, support vector machines, and they actually found that the best performing model was a support vector machine with an F-score of 0.90. So that's a very high accuracy, right? Like that's 0.90 F-score. That's a really great F-score. So I do urge you to check out this paper in your free time, and I've put the link here in case you're interested. But yeah, so this goes to show that, machine learning models are actually doing really well at solving this problem. But next, I want to talk about a much more recent issue, right? And that is, since the onset of the COVID-19 pandemic, there has been an uprising of xenophobia against the Chinese community and, in a sense, the broader Asian community. And this has not only been, there's not just been an increase in hate speech, there have actually been an increase in hate crimes against Asians, as, admitted by the FBI. So it's a pretty serious problem. So it makes sense then that the University of Georgia Tech decided to come up with a model that can detect anti-Asian COVID-19 hate speech. So for this problem, they define anti-Asian COVID-19 hate speech as antagonistic speech that has one or more COVID-19 keywords, is directed toward an individual or group of Asian people, and is abusive, derogatory, or assigns blame for the creation and spread of COVID-19. So let's move on and look at how they proceeded about this. Since this was a new problem to solve, right? The researchers had to collect a data set, and they did that by looking at the Twitter API again, and they had a list of keywords this time, and they were able to query 3 million tweets actually, and obviously that's too big. So they ended up randomly subsampling, some part of the data set and manually annotating some part of that subset. And then they used they generated a text classifier to annotate the others. This is a common practice we see, especially when we are dealing with large scale data sets, because manual annotation takes a lot of time and it's not simply feasible most of the time. But after they had their data set, they cleaned the text up and they converted everything to lowercase. And in this case, what the researchers did is that they decided to compare glove embeddings and BERT embeddings to see which one solves their problem better. And to give you a little bit of context, what word embeddings are in general is basically a vector representation of words with context. So what that means is that in a vector space, words that have similar meaning will have a similar representation and they'll be closer to each other. So in this case, maybe words that are related to the COVID-19 pandemic are in one cluster, or, they're closer together in the vector space. And words that are random, like, maybe cat, dog, sky, whatever, these words would be further apart. So there are different kinds of embeddings generated by different models, and glove embeddings and BERT embeddings are two examples of this. And they found that BERT embeddings suit their problem statement better. So then they trained multiple supervised algorithms again on these embeddings and the data set that they have now, embedded data set. And they found that although most of the classifiers, right, like the logistic regression, naive Bayes, random forest, all of them had almost the same performance, but they found that the logistic regression classifier performs a little bit better with an accuracy of 0.86. And the metric they used is something called AUC-ROC, which is basically a graph that gives you area under the curve of the receiver operatic characteristic. So what that means is that it basically plots the true positive rate against the true false positive rate at various threshold levels. So it's a really accurate metric, and it's actually preferred over accuracy and sometimes even over F-score actually, depending on the problem statement at hand. So once that's done, I guess you can see now that, machine learning models are being used very efficiently to solve this problem of hate speech detection. And if you have any background in machine learning already, you know that, uh, an ensemble approach could go a long way here. So you might be wondering that, okay, if individual classifiers are performing so well, how well can an ensemble of these classifiers perform? And this is actually a question that motivated my own research project. And currently the paper is under review. But yeah, it turns out that ensemble models can actually perform very well. And although our problem statement was a little bit different initially, like it was more along the lines of cybercrime prevention and threat detection, but definitely a part of our solution proved that an ensemble of naive Bayes classifiers, support vector machine, random forest, and decision tree could actually outperform the state of the art architectures at sexism detection, and this includes the deep learning architectures as well. So we achieved an accuracy of 97% on our hate speech detection data set. But yeah, I think one of the reasons this works so well is that, we were able to leverage the benefits of the wisdom of the crowd principle behind ensemble learning, combined with algorithms that historically perform well at text classification, even though they use, diverse algorithms in themselves. So yeah, now I guess all of this begs the question, why do we even need deep learning, right? Because if we're able to achieve, 90% accuracy with just ensemble learning and machine learning, then do we even need deep learning for this? And the short answer is yes, because even in general, like in the field of AI, deep learning does a great job at solving problems that are really, really complicated and, have constrained environments in terms of the learning, conditions that are sort of in the problem statement. So to give you some context of that, right, let me talk about my first publication, which was published at ACL. It's called Hold On Honey, Men at Work. And we basically wanted to detect sexism in popular sitcoms. And we ended up using a semi-supervised approach for this. And it was actually a very complex problem statement. So let me give you some more context of this. We basically wanted to build a model that can detect sexism in dialogues of popular sitcoms. There were quite a few challenges for this, but the first one was that there was very little data to work with in that domain, right? And manual annotation is extremely time consuming, and sometimes it's not even that efficient because of bias that is bound to creep in. And then if we look at using another domain, which is what we ended up doing anyway, the challenge was to being able to generalize across different domains. Then the shows, even within sitcom to sitcom, there's going to be some linguistic difference. And then if you look for a domain that actually has a lot of data, you're going to end up, complicating it linguistically. It's going to be more difficult to have linguistic generalization across domains. So these were some of the problems that we faced. And it turned out that the solution was a combination of deep learning, semi-supervised learning, and transfer learning. So I'm not going to get into the methodology of my paper for, in great detail for the interest of time. But we did have 3 parts of our data set, and that did include tweets. And the reason we needed tweets was that we needed to establish some sense of, training data for the baseline model. So we had tweets in there. We borrowed the tweets from a benchmark hate speech data set, and we had manually annotated dialogues, and then we had a combination of these two to generate pseudo-label dialogues. So our final data set consisted of 3 parts. And even then, right, it was a huge data set in the ending, but even then, simple supervised machine learning algorithms couldn't give us an accuracy over 55%, 56%. But on the other hand, we used a bidirectional LSTM on the baseline data set, and we found that the accuracy is 77%. So you can see, how much of an improvement there is. And finally, with the transfer learning and the pseudo labeling techniques, the while STM was able to achieve an accuracy of around 80%. So this is just going to show that, deep learning is necessary, and it's necessary in places where the problem statement is a lot more complex, right? So I do have the link to the paper here, and you should definitely check it out if this is something that interests you, because this is a bit of a niche domain, right? I mean, we have a lot of work done on hate speech for social media, but here's the thing: hate speech is not just on social media, it's everywhere, right? So this is one of those papers that ventures to like beyond social media and still looks to detect hate speech. So you should definitely check it out. Next, I want to talk about something even more interesting, which is hate speech detection in memes using something called Visual BERT. So it's no secret then that today memes are a very popular means of communication, and in some cases even a popular means for bonding, right? And there was actually a challenge called the Hateful Memes Challenge, where there was, the goal was to be able to detect hate speech in memes. So obviously you can see that this is one of those problems that combines language and vision together, right? And the challenge had hosted a meme dataset of like 10,000 memes that had to be classified as either hateful or neutral. Now, this deviates a little bit from the standard text classification task, because although it's hate speech detection, it's no longer just text classification, right? If we're looking to identify hate speech in memes, we want to make sure that we're picking up on visual cues and linguistic cues. So that's why, obviously, like, you can see how complicated a problem this is, and that's why Visual BERT was useful here, which is a deep learning architecture. So you can see here like the lines that I'm thinking along, right? Like, I want to be able to show you that deep learning is necessary for extremely complicated problems. And so let's look into how this approach was developed. Firstly, I want to point out the difference between BERT and Visual BERT, and that difference is that the latter is visually grounded. Now, what I mean by that is that Visual BERT uses transformers to jointly model words and parts of images, whereas like the original BERT model was just meant to, model words. And even though Visual BERT has actually proved, highly successful at many tasks, it's still a bit of a question, does it understand the desired cross-model representation? Maybe not, we have no way to say for sure so early on in the research community. But for this particular task, right, the Visual BERT model was able to secure a score of 0.811, and it was the winning model. So you can see that deep learning is definitely needed even in the hate speech detection domain, right? And I'm not going into too much depth into explain how this Visual BERT model works or how, the methodology was devised, because it's a bit of a crossover between computer vision and natural language processing. And it would just take too long. And I've linked both of the papers below. I definitely think both of them are very interesting, and it's something very different and something very innovative. So do check it out if you have the time. One more thing that deep learning and NLP are useful for is the multilingual hate speech detection. Because the challenge in being able to detect hate speech in multiple languages is being able to use the same architecture to understand and identify hateful speech in multiple languages, right? And as you would probably guess, if you have a background in machine learning, is that supervised learning algorithms are way too simplistic for this, and they have not been successful at this task. And multilingual hate speech detection is a very popular research field in its own right. And as of today, we have models that can detect hate speech in English, Spanish, French, Arabic, Chinese, Japanese, and even code mixed languages like Hindi and English, right? So there are a lot of successful publications in this realm. I do urge you to check it out if you're interested in this, because finally, when we talk about natural language processing, right, English is not just the only natural language out there, right? We want computers to be interfaced with us in all language, to be able to interface with us in all possible languages, right? So this is a very interesting subfield within the hate speech detection domain. And yeah, I hope I was able to explain, why deep learning is necessary in the hate speech detection community despite the performance of machine learning classifiers. And yeah, so coming forward and moving on to the next topic, which is when should we use which? Like, when is deep learning supposed to be used? When is machine learning supposed to be used for these kind of problems? Even in general, there's no good answer to this question, right? I mean, there's no firm answer. At least it's not like there's one specific use case that calls for deep learning or one specific use case that calls for machine learning. But there is definitely, a good rule of thumb that I like to use, which is that deep learning is usually a good choice for complicated problems that have a lot of constraints in the learning environment. So, like we saw in our papers that we just went over, right? If you want to look for something that's multilingual or something that needs both vision and language, basically problems that are just more complicated than simple text classification, deep learning is a good choice. But that being said, I personally feel that it's always good to try out some supervised or unsupervised machine learning algorithms at the beginning of any task just to establish a baseline, right? Because once you're able to decide, how well can machine learning classifiers do, you can really quickly tell whether the problem statement calls for ensemble learning or whether it calls for deep learning, or, basically it just helps you plan out your next steps in the modeling phase. So yeah, let's move on to the last part of our talk today, which is open source data sets and libraries for us to use. And in terms of libraries, we do have, PyTorch, TensorFlow, Keras, Python libraries like scikit-learn, NLTK. These are all open source. And if you've done any work in the machine learning community, you already know this. But what I thought it is much more interesting to discuss is that the data sets, right? We have something called papers with code, and I'm not sure how many of you are aware of this, but the papers with code has 52 hate speech detection data sets, right? So if you go to that site and you just search the term hate speech detection data sets, you get 52 results. Now these data sets are for racism detection, sexism detection. There are English data sets, there are Chinese data sets, there are even Arabic data sets. So there's a lot of data for you to already get started with. Another thing is that I have a data set hosted on my GitHub, right? And that is containing of sitcom dialogues that are annotated for sexism. So if you feel like you want to venture out into, detecting sexism in movies or in TV shows, you should definitely check that out as well. So yeah, with that being said, that's about it. Thank you for being here. I hope you learned something by coming to this talk, and I hope I was able to motivate you to look into hate speech detection problems as budding researchers or as budding AI practitioners. Thank you so much.